So, by way of introduction, today we're talking autonomy in the sea, under the sea today. And so, to get us going, Ross, we'll start with you here at the end. If you could just introduce the technology you're developing and kind of what brings you here to Abu Dhabi, to just situate all of us, everyone here in the audience, as to what you're all working on. Give us a grounding in that, and then we can, pardon the pun, dive in.
Yep, so my name's Ross Macfarlane. I'm currently the Remote Operations Centre Manager for FUGRO here in the Middle East in Dubai. And from the autonomy perspective, we've sort of got a number of initiatives ongoing. We've been in the remote sphere for about 12 years now. We focus on geodata, so it's getting information about the Earth to our clients. And we do that in a number of ways, both using conventional vessels with autonomy on board and remote aspects to ensure that we can bring as many people off of those vessels as possible, all the way through to fully uncrewed assets. So we've got a stand here at the moment. We're actually streaming live from one of our vessels, which is currently in Australia, 200 kilometres offshore in Australia.
Streaming live.
And we're streaming it live to our stand, which is just in the back here. And then from a demonstration point of view, we've got one of our 9-metre hydrographic vessels, so that's to gather information about the seabed. And that's fully uncrewed, fully autonomous. So we can give it a mission plan, let it go, and then it'll go and gather the information. If it misses, it'll realise if it misses aspects of the information, it'll come back and fill them in later and come back to us as a fully realised product.
And you called Dubai home. Can you talk a little bit about moving to the UAE and why here?
Yeah, so from a FUGRO perspective, we're a global company. We've got 4 main hubs in America and Europe, which is located in the UK. Dubai is our hub in the Middle East at the moment. Potentially that's going to be Abu Dhabi later. And then in Perth in Western Australia. So for us here, the reason why Dubai and Abu Dhabi are kind of key for us in the region is the support that we get from the infrastructure, from the government here. At my previous job was legislation, so getting approval for all of these vessels to actually operate. And from us, the Middle East and Abu Dhabi, the government here has been one of the most supportive and one of the most streamlined solutions. So it's one of the quickest routes to approval. They were very proactive. They're very interested in technology and developing. So for us, that's why kind of Abu Dhabi and Dubai are key in the region.
That's interesting. Liané, can you go ahead and introduce us to your Nemo fish?
Nemo fish, right? That's exactly it. So hello, thank you everybody for coming to this session. I'm Liané, CEO and founder of Aquaai, as in Aquaai. And we make Nemo-looking robotic fish-like platforms. And you might ask yourself, why a robotic fish-like platform? So the whole idea is unobtrusive monitoring in the waterways. So our robotic fish carry a payload of cameras and sensors, up to 16 different sensors and cameras. They stay in the water for up to a year. They inductive charge and transmit the information. But it's really not about the robotic fish. It's about the data. And the idea is, how do you get affordable data? Now, everyone knows there are a lot of different machines in the waterways that are harnessing data, AUVs, autonomous underwater vehicles. But those machines are mainly focusing on military and oil and gas. And we wanted to focus on the blue economy stakeholders that also need data but don't have deep pockets. So we're working with everyone from in Norway, fish farms, to water quality and smart city water management. We had the floods here last week. All of those waterways need to be understood in terms of toxicity levels, coastal pollution, as well as ghost nets that, everyone's seen those poor turtles that get stuck in the cages. Well, we're looking for those ghost nets that are floating to mitigate any more harm coming to the habitat, as well as biodiversity in terms of protection of coral reefs and mangroves. So our technology is 3D printed, and we offer the most affordable, easy-to-access, reliable data from waterways.
Can you talk just a little bit about Abu Dhabi and why you're here?
Sure. So we're a U.S. company headquartered in California. For the last 4 years, have been operational in the north of Norway, predominantly in the Arctic Circle, really rugged testing our technology in sustainable fish farms that provide Whole Foods and Michelin chefs with sustainable salmon. And we had quite a bit of demand from the region. We were fortunate to participate in NEOM Food Accelerator. And based on that, it really kind of opened our eyes to what was going on in the MENA region. So we were looking for a soft landing here, because there is the UAE Water Scarcity Strategy of 2036 and the Integrated Water Management Plan, which is a great plan, but we need tools. We need like a John Deere tool for the waterways. And so that was what we're bringing here. is that tractor that can be used in so many different use cases, but it's simple and doesn't break the bank. So we opened up a facility here by thanks to ADGM and Hub 71 that brought us here. And now I've been living here since the end of October, and I have to say I love it. No intention of leaving. We're setting up trials with different governmental entities and partners and corporate partners. And we're looking for many other partners to come and join us on this journey as we expand our manufacturing facility here in the UAE to service the entire MENA region.
Awesome. Thierry, you are, as Liané referenced, oil and gas and defense. So talk to us about Manta and what you're all doing at Marine Tech.
Okay, I'm Thierry Carlin. I'm the chairman and founder of Marine Tech. Marine Tech is a small-sized company. We are based in the south of France, in Toulon. Toulon is the first military harbor with the European countries. And we have the chance with the French Navy and the French government we have developed a brand new technology. It's a marine drone with special advanced solution on it. We call it UHV Manta for unmanned hybrid vehicle. It is hybrid for his mission because we combine the mission of a boat. It's a boat and a submarine together. So it's a remote system that can operate from the surface, but can also dive down 6,000 meter water depth. And UHV Manta, you can see an example of it just at the entrance of the exhibition. So it's a brand new system. It's a new solution to acquire data from the surface to the water column and to very great depths, 6,000 meters.
And you have a partnership with Bayonat that I'd like you to talk about because it's why you're here in Abu Dhabi today.
Yes, we are very proud to participate to the strategical development with Bayonat because, as you know, Bayonat is one of the leaders of acquiring data from the air, from the space, and from the sea. And we bring to Bayonat this capability now to acquire data, to process the data to the water column and also to very deep areas. So we bring them the 3D aspects of the data.
We'll talk more about how you secured that partnership after. Stefano, please tell us about OCEANDRONE.
Thank you. It works.
Hello.
It's important. I'm Stefano Malagodi, co-founder and managing director of OCEANDRONE. OCEANDRONE is a company devoted to U.S. vessel and maritime robotics. We develop this uncrewed surface vessel for long endurance mission. As the sea is very big, the extension of the sea is large, and one of the problems is the endurance. So the only way to increase the endurance is reducing the loss of performance in terms of energy transmission and mechanical transmission. So the easier way is to use the wind. So our proposal, our prototype, our design is back to the future, basically. We use wing sail and solar cell in order to have a zero emission vessel. The system is quite sophisticated because it's completely controlled by autonomous and artificial intelligence control system. We have a proprietary system, both in terms of wing sail, there's a European patent with extension on the world, and the control system. Why the UAE? Because I think it's a Euro request. According to some study confirmed by the University of Strathclyde, one of the best places to use such kind of technology is the Arabian Sea, because there is wind and sun. So in this way, we can have a very long endurance with zero emission. You can imagine having 5, 6, 10 of such kind of drone. Basically, you can cover all the Arabian Sea.
What is the use case for such a vessel?
We have a prototype here, just around the corner.
Okay, we'll go check it out. Sam, can you tell us a bit about your vessel and why Abu Dhabi today?
You all hear me?
Yes.
Loud and clear? Okay. So LuftCar is based in Florida. We're based in Tampa. We do a lot of work in Miami. We are doing two things. We're doing autonomy. We're working with an autonomous company and integrating autonomous navigation. But that's not what I want to focus on. We are working on a true last mile delivery to remote destinations. So we are building a flying forklift powered by hydrogen. So it's a hydrogen fuel cell electric vehicle, and it works the same way a pitcher holds a baseball or an eagle carries a prey. So we can carry pretty much anything, like a road car or a boat or even an underwater vehicle. So I developed this concept coming out of L3 Harris to serve the underwater vehicle industry. Now, we normally deliver underwater vehicles by hand, going into a boat to the conflicted zone and put the underwater vehicle down. But now with our vehicles, you can fly them from a surface ship, clamp the underwater vehicle and retrieve it, and also launch it. We can also launch water vehicles, flying water vehicles across land. We can also carry road cars. So we are combining air mobility and sea mobility. We are right now developing our first prototype, where we have done our digital twin, and we are partnered with Bosch and a few others in the hydrogen space. But hydrogen propulsion is something that we can supply to anybody that's looking for hydrogen propulsion.
Why hydrogen? I'm curious. I mean, so Stefano just referenced infinite solar and wind power. Liané, you can go out for a year. You're battery powered, right? You recharge. Ross, how are you guys powered?
We're a hybrid, so diesel electric systems.
Okay, so I want to talk about the decision of how you power these vehicles. So hydrogen for you,
why hydrogen
there?
Why hydrogen? Hydrogen fuel cells have 4 times the energy density than batteries. Particularly in a maritime situation, you don't have to recharge these. You don't have to pull your vehicle out, go to a bay and recharge it. You can just fuel hydrogen, get 300 miles out of it, 500 miles out of it. Very much like gasoline use case, but hydrogen handling is a lot easier. And what we want to do in Abu Dhabi, to your earlier question, is we want to bring these hydrogen vehicles in. We want to bring our hydrogen propulsion manufacturing in Abu Dhabi. And also we want to build these vertiports, or these launch places where hydrogen is available for refueling. We have partnered with several companies in the United States to make that hydrogen refueling infrastructure available. We were part of the Northeast Hydrogen Hub program from New York, and we want to leverage our know-how in building vertiports here in Abu Dhabi and Dubai.
Super interesting. Liané, can you talk a little bit about the 1 year out at sea challenge and how you keep your vessels out for as long as you do? And Thierry and Ross and Stefano, I also want you guys to speak to the power question.
So for us, it's unique. A lot of people, a robot fish, why a fish, right? If you look at 20 million years of evolution in the water, you see marine habitat, they look and swim, and they are fish. So we actually use the undulation of the tail as a major power source. We swim with the current, so it's incredibly efficient when it comes to battery powering. And then we inductive charge. So we go to the surface, and that's obviously where we also transmit the information, is through inductive charging onto the surface. In terms of the challenges of going deeper and deeper out at sea, we have a couple of methods. So in the case of the fish farms in the north of Norway that are offshore, we're sending the data and such and charging through their kind of barge. What we have actually done a white paper with other surface vehicle companies where our robots are in the hull of that surface vehicle that goes out in further distances, and then we're deployed to do things like monitor the corals or whatnot that's subsurface. And then when we come back into the hull of the ship, that's when we charge and transmit the information. So we don't go out to sea, but we kind of hitchhike and catch a ride on some of the surface vehicles to go out at sea. and why they would use us for corals or even some of the one use case that was asked of us, or the windmills or the rigs, is because of the maneuverability of the tail. Most drones underwater don't have that turning radius, but we're able to get in small spaces because of the maneuverability of the tail.
Yeah.
Yes, for us it's quite the same. We look at the nature, we look at the fish, and we discover that if we want to increase the range of operation, and so we need to look how the fish are moving. And the drone that we have designed, the one that you can show here, it looks like a manta ray. And his name is UHV manta. This is for the reason. And why? Because the shape of a manta ray is, we are inspired by the nature. With this shape, we are able to reduce the drag, so we save a lot of energy. So our ambition is to stay weeks and even months under the sea acquiring data. And also the manta ray has the capability to move in 3 axes as a normal submarine cannot do. So by looking at it and by designing this shape and by deploying like this, we benefit of a lot of advantage. Saving energy, having the capability to move on the three axis direction, staying on the seabed, waiting for information, going back to the surface, and so on. So definitely the nature inspire.
That's interesting. Ross, can you speak a little bit to the power question and how you...
So for us, it's all about the use case, because essentially what we're moving towards is trying to replace our conventional fleet. So I mean, we're running high-powered survey sensors, we're running a fully electric ROV, and these all draw a lot of power, as well as the reality of the speed of the vessel needs to be commercially viable as well. So for that's where this hybrid diesel-electric system comes in. So if you compare it to conventional fleet, it's about 95% more efficient than what we're currently running with the conventional vessels. And we've looked at other solutions. So we're currently, one of our partner companies, Seekit, is developing a hydrogen solution to work with the Port of London. But the use case there, it works because it's short durations of period. Because if you start looking at alternative fuel sources, you're either looking at either less power output or the volume of fuel that you need to take. Then either you need to start taking other aspects away from the vessel or just reducing the endurance. So for what our vessel that we're showing on the stand today, we've got a 21 days endurance period, which ties in with all the maintenance periods as well. So we can run a full operation for 21 days with 95% efficiency of what we would have done with one of our 120-metre vessels.
Super interesting. Santh, I'm hoping you can talk a little bit, if Stefano will give up his microphone, but you'll give it back because he's also going to answer this question. Talk a little bit about where we're at in this innovation arc. All of you have made decisions around even how to power your vessels, and that sounds like an elastic decision. You're all kind of innovating and you're making all these decisions. Where are you at in the innovation arc? How cooked do you feel your vessels are? Are you in the prototyping phase? Are you in the, I feel really good about this, and this is the last generation vehicle we'll produce? Or are we really in early days when it comes to marine autonomy?
So we call our vehicle the next generation eVTOLs because we are using co-flow propulsion, we're using hydrogen fuel cell propulsion, and we are using an airframe that could be customizable to carry any kind of cargo. So it's the next generation aviation, and we are developing a prototype. We don't want to develop any eVTOL vehicle because that's been done. What we want to develop is a vehicle with a unit airframe that can carry cargo for last mile, and that's what we're doing. We have finished the digital twin. We are halfway through our prototype development, and we'll be finishing our prototype, a 6-foot prototype. And I was planning to bring it here, but we are a little bit behind on it. So we'll finish our 6-foot prototype by summer this year, and a 2-seater prototype by 1 year from now.
So prototype is your answer. You're in prototype mode.
Yeah, we have to call out of this prototype because until we go through the whole certification exercise with the Federal Aviation Authority, we cannot call them commercial models. Mm-hmm. But we will have customers that will buy these vehicles and that will test these vehicles for us. In fact, we just signed an agreement with a dealership here to sell our vehicles. So we'll do a lot of customer validation on these prototypes. They kind of put commercial in. Okay.
There is one issue that is not the choice of the energy of the power source is related to the regulation, international regulation. When we start OCEANDRONE, we start working with fuel cell. Later, we had to move to lithium battery, mainly for regulation reason. Actually, for such kind of vessel, USV, there is no common agreement around the world. So every country, and sometimes in the same country, different Coast Guard department issue different regulation. So it's very difficult having form lying in the choice of the energy source. Because sometimes it's better for cell, but it depends. If the local Coast Guard or the local state let you carry hydrogen on board, and in order to have a good hydrogen source, you need the gas. For our prototype, we ship our prototype by air freight from Europe to here with no battery. And we have to buy lead battery here. Actually, there is no sole unique regulation around the world for such kinds for the small vessel.
Okay, so that's an interesting thing you're highlighting, which is there's not really universal standards for this area of autonomous development. Thierry, you work with major military partners, government agencies. Can you talk a bit about what the hurdles are you're still facing? You're operating at a very high level, but what are the hurdles for you? Is it regulatory? Is it engineering? Is it the science? What still challenges you?
I think things are moving very fast. We can see with the war in Ukraine and so that they use drone and so small drone and they disturb the basic organization. I think the main challenge is the technology. For instance, the batteries, because everybody wants system that stay as long as possible on the air, on the land, and the batteries remain a real problem. For sure, there are some nice solutions like you are doing, but I think the energy is one of the challenge. And for instance, for us, we are looking for the next generation battery. Lithium battery is what everybody is using, but we are thinking now and we are working with partners and military partners to have the hydrogen next generation battery, because hydrogen for us is a way the industry has to go. For sure, when you want to bring hydrogen in deep water, you are facing some pressure and so. But there are some solutions, and we are working on it with some partners.
Yeah, and I'm hoping you also get. I've heard you speak very passionately about the funding environment for the work that you're doing, and I'm wondering if you could address. You're the startup, I think, here in this lineup, and I'm wondering if you can address just the funding environment and challenges to. Do you access venture capital funding? Do you pursue perhaps an industrial scale customer? How do you decide?
Sure. So yes, we are a startup. I think a couple of things. One, we're a climate startup. So we weren't going for the offers that might have come our way through different military, oil and gas, and so forth. We, for the most part, have grown through customer paid trials, down payments, NREs. I do think that when you look at the funding environment for climate, that it has to be patient capital. So most of our cap table looks like angels and family offices. We do have a handful of VCs who are patient, who are new to the space. Adam Draper at Boost VC, Arlen Hamilton at Backstage Capital, and Ad Astra, a couple of firms in the U.S. that are patient, either supporting females or supporting climate or supporting frontier tech, and that's what I really want to tap on. I think it's difficult for everyone, startup or not, when you're working in frontier tech, that this is an unknown, and everyone who's doing stuff in space gets financing thrown at them. But yet, you go subsurface, which is, as everyone knows, is a bigger mystery than space at this point. You don't necessarily have all those funding dollars thrown to you. But yet, anything you take subsurface is incredibly expensive. So the funding dollars do need, and I think everyone on this panel agrees with me, does need to flow more towards frontier technologies doing these great, amazing missions subsurface, whatever your mission may be. And you're never really quite done. You ask about the prototypes. In this world, in frontier technology, a camera 10 years ago is not even on the market, or 5 years ago. You're always upgrading. You're always developing in robotics and frontier technologies, deep technologies. It's changing so rapidly. And there's a handful here who are keeping up, constantly looking at how they can better their systems, how to make them more diverse, whether you're going from sea to flying like the gentleman beforehand, or us sea, maybe walking in our future as well. So yeah, I think that if people want to embrace climate or frontier technologies, there needs to be more funding dollars, not just from corporates, not just from governmental entities, but also from the investment world.
Ross, can you speak a little bit? I've forced Liané to focus on financing, but you can pick your flavor. What hurdles are you guys facing? Is it regulatory, engineering? What are the...
So I think for us, the technology works. It's day to day for us now. This is our routine operation. The issue that we've got is, I think I'm probably right in saying that the maritime industry is probably the second most heavily legislated environment of all of the behind aviation. And what we're actually finding is that it's maybe a bit over-regulated for what we are trying to do. And what I mean by that is maritime legislation has evolved over time for the safety of humans at sea. So like SOLAS came around after the Titanic. And because of that, when you then start sending a vessel offshore with no people on board, you find out that there's a whole bunch of things that you have to comply with, which are completely irrelevant. And it then becomes a case of justifying why you don't have to comply to that, rather than how you can comply to it. So I mean, you need to go through all the different levels. You need to go through the international level, the local level, and that can be, depending where you're operating, can be coastal and inland waterways, can be two separate things. Luckily, we're quite lucky here in the UAE that they've got a very cohesive system, so it's all joined together, which makes it a bit more straightforward. But then you've got the client regulations, you've got classification regulations, so there's this whole network of people that you have to justify yourselves to that you're safe to operate. And then if you go from one client to the next client, they're not going to accept the evidence package that you used for the previous client, so they need to go through the whole process again to put it in a different light. So for us, the most time-consuming thing is sort of reiterating in that constantly to justify and prove ourselves that we are safe to operate.
Sure, that's super interesting. Santh, I want to come to you in closing. I'm sorry, our time is short, and there's so many of us here on stage. Cast out into the future for me a little bit. What do you predict in the decade to come for this technology? I want each of you to briefly answer that, and then
we're going to have multiple configurations of air vehicles. Urban air mobility will not have one configuration doing something. It's not going to be a homologous market. Going to be like customization of airframes. Going to be different propulsion systems. Hydrogen and battery will coexist peacefully. So that's what I heard.
Thank you, Stefano.
I think that there will be concentration. They're quite optimistic, but now the market scenario is quite jeopardized. We see here many companies. Each company has an excellent idea, good idea, but in order to survive the market, you need the volume. So for sure there will be a concentration. Here we are. Our host is Bayanat, and Bayanat is doing a concentration of company, collecting different benefit for each one. FUGRO is different. It's a conglomerate. They control from the manufacturing of the vessel to the data analysis and the selling of the data. So it's quite different. But for small company, there will be for sure a concentration.
Saying Thierry? To double mic?
No, for us, this strategic and partnership with Bayanat is very important because the country is is growing so fast, and also they are pushing this advanced technology. So we are really proud to be here and to bring some solution all together.
Liané, your boldest prediction?
Prediction?
Yes, where are we going? Where is this technology going in the decade to come?
I think the technology definitely is going subsurface. I do think biomimicry is the future of robotics, whether you're actually in the air or subsurface. So, and multifaceted, swimming and walking, swimming and flying. And if you would like to see our technology, we are here. We have a booth. We're right there near the silver doors. So please come and see our robotic fish. And thank you.
Ross, you get the last word. Boldest prediction.
I don't think, I'm going to, maybe this is a bit controversial, but I don't think there's too much to predict, because I think all the technology that we're seeing here today is just going to become commonplace.
Okay, mainstreaming, one word, mainstreaming, the mainstreaming of the technology we're surrounded by. Thank you so much, Ross, Liané, Thierry, Stefano, and Santh. Thank you for being here. Thank you for your time. Thank you all.